Hi guys, this is Hw6. I'm doing homework 6, question number 1. We're given that f and y have joint density function fxy equals bxy when 0 is smaller than or equal to x, smaller than or equal to y, smaller than or equal to 1. First part, we need to find b. We know that since it's joint density function, the double integral of fxy has to be 1, and the range for x is from 0 to y, and the range for y is from 0 to 1. So we plug in bxy for the function fxy here, and we take the integral for bxy dx first, and we get by times half of x squared from 0 to y, and we take this integral bounded by y. So then we get this is just simple calculations, and we do 1/8 of b times y to the 4th from 0 to 1 is equal to 1. So we get 1/8 of b is 1. Thus b is 8. So the second part of this question needs us to find and sketch the marginal density function fxx and fyy. Fxx is just the integral of fxy, and we get b is equal to 8 from part A. So now we just plug in the b value to the original function. So we get fx of x equal to the integral from x to 1 at 8xy dy, and we have 8x times half of y squared from x to 1, and we get 4x minus 4x cubed for fxx. And for fyy, we have the integral of fxy dx, and the range for x is from 0 to y. So we have 8y times half of x squared from 0 to y equals to 4y cubed. And the graph for fxx looks like this, and the graph for fyy looks like this. Okay, so part C, prove or disprove that xy are independent. If xy are dependent, then fxy equals fxx times fyy. So we got this from part A. We know that b is 8, so fxy is 8xy, and fxx is 4x minus 4x cubed. And then fyy is 4y cubed. So the multiplication of fxx and fyy doesn't equal to fxy. So xy are not independent because they are not equal. Now for part D, the question asks to find the expected value of x, the expected value of y, and the expected value of xy. For the expected value of x, we simply just take the integral of x times fxx dx from 0 to 1. And we know from part B that our fxx is 4x minus 4x cubed, so we just do the integral and find that the final answer is 8/15. For the expected value of y, it's the same thing as how we did the expected value of x. We take the integral of y, fyy, dy from 0 to 1. The integral gives us 4/5. And for the expected value of xy, we take double integral this time and of the function fxy. So we do the integral for dx first. So in this case, 8y squared will be constant, so we take it out and we get 1/3 x cubed from 0 to y. This will just be 1/3 of x of y fifth. And now we take the integral for 1/3 y fifth from 0 to 1, and we get 4/9. And now for part E, we need to prove or disprove that x, y are uncorrelated. We know that the correlation of x, y is equal to the covariance of x, y over the square root of sigma x squared times sigma y squared. And the covariance of xy here is just the expected value of xy minus the expected value of x times the expected value of y. And we already got this part from part D. We know that the expected value of xy is 4/9 minus the expected value of x, which is 8/15, times the expected value of y, which is 4/5. And we get this, which is not equal to 0, and that proves that x and y are correlated. Now for part F, we need to find fy given x, which is the function fxy over fx. Fxy from part A, we know it's 8xy. Fx, we got it from part B. We know that's 4x minus 4x cubed, which is 2y over 1 minus x squared. For fx given y, it's just fxy over the marginal density function fyy, and it's 8xy over 4y cubed, which is 2x over y squared. And this plot is for fy given x. This plot is for fx given y. When y is when x is when x is 0, we know that the graph is just 2y. And when x is 1, when y is 1, when y is 1, we know that the graph is just 2x. So it looks like this. For part G, we need to find the expected value of y given small x, the expected value of y given big X, the expected value of x given small y, and the expected value of x given big Y. And the expected value of y given small x is the integral of x times the the conditional density function Fy given x dy, and we just plug in what we got before, the marginal density function of y given x, which is 2y over 1 minus x squared, and we get 2 over 3, 1 minus x squared. And for the expected value of y given big X, this is just the expected value of xy over the expected value of x. And we know it from part D that the expected value of xy is 4/9 and the expected value of x is 8/15. And this gives us 5/6. So the same thing for the expected value of x given small y is the integral of x times the conditional density function x given y. And the integral, and we know this conditional density function is 2x over y squared when we plug it back in, and then from 0 to 1 we get 2 over 3y squared. And for the expected value of x given big Y is just the expected value of xy over the expected value of y, which is 4/9 over 4/5, and that gives us 5/9.